All right, y'all. I've got about 20 minutes. Let's see if we can get through this in 20 minutes. The joy and the beauty of a video is that you can pause it if you feel like this is too fast. Feel free to slow it down, pause it, do what you need to do. But this is for my kiddos who tried their best but did not succeed on that exit ticket yesterday. So, our notes yesterday. What is a kite? A kite is a quadrilateral with two pairs of consecutive sides that are congruent. And so in this kite right here, that's this side and this side is congruent to that side. And in a kite, one pair of opposite angles are congruent. The opposite angles that are congruent are the angles that live between the two sides that are not equal to each other. So this side does not equal that side, and the angle between those sides is congruent to the opposite angle. In a kite, diagonals are perpendicular, meaning the diagonals cross at a right angle, making four right triangles. So let's go ahead and draw in our diagonals. We're going to add that right angle symbol there. And in a kite, one diagonal is an angle bisector. So one of these diagonals is splitting angles in half. This is not the one that's doing that. This diagonal splits this angle in half and that angle in half. And so we're going to show that with double arcs here, triple arcs here. And our last property is that one diagonal is bisected. So one diagonal is a bisector, one diagonal is bisected. So one diagonal is doing the job of splitting angles in half. The other diagonal is being split in half. And the diagonal that's being split in half is this diagonal right here. And so let's apply all of these properties on these three problems. Our first problem asks us to find the measure of angle R. Well, something that we should be approaching these notes with is the knowledge that the angles in a quadrilateral add up to equal 360. And now, new info is that, hey, those two angles are congruent. And so, if I want to find the measure of R, I have to find X. To do that, we're going to add up all our angles, X plus 30 plus 125 plus X plus 125. All of those angles add up to equal 360 degrees. When we combine like terms, we're going to find that 30 plus 125 plus 125 is 280, and that X plus X would make 2X. So we have 2X plus 280 equals 360. When we subtract 280 from both sides, we get 2X equals 80. And if 2X equals 80, then X equals 40. X equals 40, but that does not answer the question, what is the measure of angle R? And so to figure that out, we have to plug in our X. If angle R is 40 plus 30 degrees, then the measure of angle R is 70 degrees. So, moving on to our next problem, we're going to apply a different property. The only property that we applied on this problem was that one pair of opposite angles are congruent. The rest of the info was prior knowledge. So for this problem, the information that we're going to have to apply is the idea that the diagonals are perpendicular and the right triangle world that is opened up when that happens. So it says find the length of ME. So how long is this, given that diagonal KT is 56 units long. So diagonal KT is the diagonal that is getting split in half. So if KT is split in half, then half of 56, we are going to find that this is 28 units long. And so next, to figure out the length of ME. ME is a leg on a right triangle. And so we have two sides on our right triangle. We're missing the third. We're going to use Pythagorean theorem to figure out the length of that leg. And so Pythagorean theorem, a squared plus b squared equals c squared. We have 28 as our a plus our b squared, because we're looking for a leg, equals 35 is our c squared. We're going to subtract 28 from both sides. We always subtract whenever we're finding a leg. And we get that b squared equals 441. Now, our last step in Pythagorean theorem is always to take the square root. And so b equals 21. And so the length of ME is 21 feet. For our last problem, all we're using one more time is the idea that one pair of opposite angles are congruent. And so I said that we're only using this on this problem, but we also use the idea that one diagonal is bisected. We use that here as well. But let's apply here. One pair of opposite angles are congruent. What opposite angles are congruent? Well, we can see y is not equal to w. They have different measures. And so it must be x and v are the opposite angles that are congruent. And so while we could write that this is 8x minus 5 and then write 8x minus 5 plus 115 plus 8x minus 5 plus 95 equals 360. I don't think that is the best problem-solving route to take. What we're going to do is, if we know all the angles add up to equal 360, we're going to add the two angles that we have, 115 and 95. And we get 210 degrees. And so now we are going to subtract that from 360. 360 minus 210, we end up with 150. And so that doesn't mean that x is 150 nor v. But what that means is that we have 150 degrees left in our quadrilateral to split between these two congruent angles. So we're going to divide that by 2 and find that each of those angles is 75, meaning that 8x minus 5 equals 75. We're going to add 5 to both sides, and I get 8x equals 80. Divide by 8 on both sides, and we find that x equals 10. And we've accomplished the task that we've been asked to do. And so that's that on kites. Let's learn about trapezoids. So what is a trapezoid? Well, it's a quadrilateral, and it's a quadrilateral that has one pair of opposite sides that are parallel. And so this side is parallel to that side, and those parallel sides get special names. These are our bases, and then the other sides are known as legs. And because we have parallel lines cut by a transversal, these same side interior angles are supplementary. And so instead of calling them same side interior angles, we call them consecutive, one after the other, non-base angles, because they're not on the same base. And so those angles are supplementary, meaning they add up to equal 180. And so this is really the only thing that's special about a trapezoid until you get to an isosceles trapezoid. And in an isosceles trapezoid, legs are congruent. So this leg is congruent to that leg, and we still have those parallel bases. The base angles are congruent. And so These two angles are congruent. These two angles are congruent. And the diagonals are congruent as well. We're not going to draw in the diagonals. I just think it makes the picture a little bit too busy, but this is a really important thing to know. And then the last thing, it's kind of a bonus property in isosceles trapezoids, opposite angles are supplementary. All right, so let's apply these properties on these problems. First, I'm going to look at the problem and determine, do I have a normal trapezoid or an isosceles trapezoid? And it's just a plain Jane right trapezoid. And so these angles, these non-base angles, these consecutive non-base angles, these angles are supplementary, meaning 12x plus 3 plus 13x plus 5, those two angles add up to equal 180. And so we're going to combine like terms and find that 12x plus 13x is 25x, 3 plus 5 is 5, and we're going to continue to get x by itself, isolate our variable. And so we start off by subtracting 5 from both sides. We get 25x equals 175, and divide by 25 on both sides, and we find that x equals 7. All right, next we're told that trapezoid DON is an isosceles trapezoid. Quadrilateral DONE is an isosceles trapezoid. So what does that mean about our trapezoid? It means that these base angles are congruent. It also means that these legs are congruent and that these diagonals are congruent. We're told that angle EDO is 110 degrees. And we're told that angle DEN is 15x minus 5 degrees. And so angle D and angle E, what is their relationship? They're not congruent because they don't have the same number of arcs. They are supplementary, just like this last problem. And so a couple ways you can approach this. You can say 15x minus 5 plus 110 equals 180. That's an option. But another option that I prefer is I'm going to subtract 110 from 180 and know that this angle right here is 70 degrees. Therefore, 15x minus 5 equals 70. Add 5 to both sides. 15x equals 75. Divide both sides by 15. And we find that x equals, let me consult my calculator, 75 divided by 15, we get 5. For our last trapezoid problem, it's not isosceles, it's just a trapezoid. And we're asked to find the missing angle measures. So we want to know the measure of angle A, and we want to know the measure of angle C. And so to find that, we need to understand that angle B and angle A are supplementary. And we need to understand that angle D and angle C are supplementary. And so if B and A add up to equal 180, then I can do 180 minus 76 to find the measure of angle A. And I get 104 degrees. And to find the measure of angle C, all we have to do is 180 minus 143. And we get 37 degrees. So this is 104, and this is 37 degrees. And so those are our important properties of a trapezoid. And for those of you who attempted the practice, This problem is very similar to the problem on your practice. It's the same picture, a couple of the numbers are a little bit different. And so let's go on to the back with our 6 minutes left and talk about area. And so what are area formulas that you should be familiar with at this point in geometry? Some of these are old news. Triangle and circle, we haven't talked about those. You learned about those in middle school. But the rest of these are all area formulas that we have worked with in class. And so we're just going to refresh our memory on these formulas and then practice finding area. And so the area of a triangle is 1/2 base times height, where this is our base, this is our height. Area of a rectangle is base times height, or you could say length times width. Area of a parallelogram is base times height. Area of a circle is pi radius squared. Area of a rhombus, we discovered the other day, is 1/2 diagonal 1 times diagonal 2. Area of a trapezoid is 1/2 base 1 plus base 2. It's our only area formula that requires us to add times the height. Kites and rhombuses have the same exact formula for their area, so it's 1/2 diagonal 1 times diagonal 2. And last but not least, our area of a regular polygon is going to be 1/2 apothem times perimeter. So maybe I can get through these lightning fast. Let's try. Here our radius is 4 feet, and so if area of a circle is pi radius squared, then the area of the circle is pi 4 squared. We're going to leave our answer in terms of pi. 4 squared is 16, so our area is 16 pi square feet. Here, if our area is base times height, this is a square. We're assuming it's a square. So our base is 10, our height is 10, so the area of this square is 100 square inches. Our triangle area of a triangle is 1/2 base times height, where in this triangle our base is 10 and our height is 6. I don't need a calculator for this. I know that 10 times 6 is 60, and half of 60 is 30 square yards. For our parallelogram, area equals base times height, and in this parallelogram, our base is 35, our height is 21. I do need a calculator for this one. 35 times 21, I find that the area of this parallelogram is 735 square kilometers. Trapezoids, so much work, but here we go. Area is 1/2 base 1, 5, plus base 2, 11, times the height, 8. 9 is not the height, it's the length of the leg. The height is always going to be perpendicular to the base. And so our area is half of 16 times 8. Half of 16 is 8. 8 times 8 is 64 square yards. Here, these arrows are pointing smack dab to the middle of this segment. So that means that our diagonal is not 6, but rather our diagonal 1 is 12, our diagonal 2 is 8. And the area of this is 1/2 of 12 times 8. And so I'm going to do this like this. 1/2 of 8 is 4. 4 times 12 is 48. 48 square yards. I'm going to skip over this last trapezoid and move on to the kite and regular parallelogram. And so for our kite, area equals 1/2 diagonal 1 times, oh, my Apple Pencil just died, times diagonal 2. And so our area equals 1/2, e.g. 10, 7, 1/2 of 70 is 35 square inches. One last problem. One area for a regular polygon is 1/2 apothem times perimeter. And so our apothem is 16. Our perimeter, I have to do 23.2, one side, add up all the sides, so times the 5 sides, and I get 116. And when I multiply that all together, I get 928 square units. So I hope this helped you out and gives you a little bit more clarity on these topics. And cool.